Welcome to clickmyproject.com.
Yeah, let us discuss about the delay-aware wireless power communication networks, energy balancing and optimization. Yeah, let us discuss about the abstract of the product. So, in a wireless power communication network where user equipments harvest energy radius source from an access point and send to the data AP, there exists a near-far problem with respect to energy harvesting efficiency due to the user's random allocation. So, in this work, we introduce the concept of delay-aware energy balancing by minimizing the energy transmission delay while taking into the account of issue of unbalanced harvest energy distribution. So in particular, we propose an adaptive harvesting then cooperative protocol where sends the data to AP directly or via the UE existing relay in a combination of transmission power and routing topology by matching load and energy distribution in the network. So while minimizing the average transmission delay, furthermore, to avoid the data flow in the UE relay to determine the combination of the delay, we approximate the average of Markov decision process and propose a low complexity sample path based algorithm to obtain a near optimal solution. So in this proposed system, efficient spectrum sharing approach is proposed where narrowband channel is sensed frequently. So the deductive available channel is used to transmitting the aggregated data with effectively. So apply two approaches using wideband sensing based spectrum sharing scheme and a wideband uptrend spectrum optimal sensing time and power allocation strategy are implemented. So finally analysis the ergodic throughput of the system and also to balance the energy distribution while minimizing the transmission delay. Yeah, let us discuss about the flow diagram of the process. So these are the overall flow diagram. So in the system model, first of all the system model. So in the system model we detecting the probability of detection, so that is PD, and probability of false alarm, so that is a PFA, and then received signal estimation. So these are the system model of the property, and then PWSS scheme. So that is W is a wide spectrum analysis of the process. So in this process we calculating the wide spectrum sensing to how to share the spectrum by using the transmission rate of the process. So again the PWSS scheme is converted into the transmission rate estimation. So in this scheme we calculate the transmission rate by using the wide spectrum sharing by using the equations and to solve the transmission rate estimation, because the transmission rate is important to calculating the spectrum sensing of the process. And then we analyze the total ergodic throughput of the process. So in the total ergodic throughput of the process we calculating by using the transmission rate estimation. So overall the process by using the equation and then we do find the total ergodic throughput. And then we calculating the optimal sensing time and power allocation of the spectrum sharing. So in the optimal sensing time we calculate the power allocation of the process by using the total ergodic throughput. So total ergodic throughput first we calculate it and then calculate the optimal sensing time, how much time to spend the sensing the total ergodic throughput and to allocate the power channel to all the places. So and then calculating the optimal values for multipliers. So optimal sensing time, calculating the best time of the sensing, and then optimal value of multipliers is predicting the best value to get the multiplier. So if optimal value coverage, so that is the process is coverage, the process is going to performance analysis. If else, again the process is called to the optimal sensing time. So optimal sensing time, we calculating the best time of the process and then calculating the optimal values for the multipliers. So that is a process to if optimal value of the converge. So if the process is yes, the performance analysis will get. If the process is no, the optimal sensing time and power allocation should be. Again the process is completed for the multipliers. So these are the overall flow diagram of the process. Yeah, let us discuss about the running procedure for the product. So click the main file and then run. So there are many outputs related to our flow diagram. So in all the outputs, that is first of all the first figure is denoted by, in this first figure this is the average throughput between the power of average and the throughput bit per second per hertz. So the HTC is a cooperative, so harvest then cooperative and harvest then harvesting. So these are the two approximative value. So this is the throughput of the average throughput calculating by the harvest then cooperative network. So the throughput will be calculated by bits per second and also the hertz of the product. So the next Yeah, so this is the next figure. In this next figure, we calculating the average data rate. So average data rate between the HTC and HTT. So these all the average data rate. So these are the data arrival rate. So up to 10 to 50. So these are the data arrival rate, and then these are the average data queue. So average data queue will be calculated by the data how to following the queue and then get the arrival to the particular destination source. So this is the figure of the average data rate by calculating the average data queue by using the data of arrival rate. Yeah, so this is the next figure. In this next figure, average throughput of the proposed protocol with different relaying schemes. So these are the different relaying scheme between the average throughput of the bits per seconds per hertz. So HTCC OR and PRS1 and PRS2, and then harvest then transmit. So harvest then transmit by calculating our proposed work. So these are our existing method by calculating the different relay scheme. So there are the different relay scheme OR and PRS1 and PRS2. So these are the different relay scheme. So there are two conditions. One is approximative and another one is asymptotic method. So by calculating the average throughput of the average power of the ratio. Yeah, this is the next figure. So this is figure also a PA and average throughput delay between the HTC approximation and then harvest and transmit. So these are also the different relaying scheme between the PA and throughput of the value. So throughput is 0 to up to 1. So this is a 0.9 and 0 to 1. So by calculating the value, approximating PRS1 and harvest and transmit of the product. Yeah, this is the next figure. So DSR, the distance is equal to 3m by calculating the optimal value of tau. So by calculating the tau of the average power by using the HTC, OR and PRS1 and harvest and transmit. So these are the different relaying scheme by calculating the optimal value of tau. So basically our flow diagram calculating the optimal value of tau regarding to the average power by calculating the DSR and different relay scheme also. Yeah, in this figure, average packet drop by calculating the average energy harvesting ratio and then packet drop. How many packets are dropped by using the energy harvesting ratio by using the different relaying schemes. So HTC OR and HTC PRS1 and HTC PRS2 and then harvest and energy transfer by using the 10 power 4 by calculating the packet drop rate of the average, calculating the average packet drop of the energy harvesting ratio of the process. So yeah, in this figure by calculating the average data queue length and packets. So how many packets are presented in the queue and then energy harvesting by using the different relaying schemes of the process. So average data queue is data are formed by the queue and length of the packet. So how many packets are presented in the energy harvesting method. So these are overall running procedure for the product.
Thank you for listening this video.